So we have the same region as we had in the last problem, but this time we want to rotate it around the y-axis, and we want to use the shell method to find the volume of the solid formed. So if we are rotating this region around the y-axis, let's just kind of darken that in so we can see that, our representative shells will be parallel to that axis, so they are going to run like this. So when we figure this out, this is the h, and then when we wrap it around here, that is the 2 pi r piece. So we can see this time our little thickness is dx. So when we do our integral, we will write things in terms of x. We will need to go from where the x is 0 out here to where the x is 2. And we've got 2 pi r. And we can see as we're rotating that the r would be the x value here. Wherever we made our specific shell, it would be x value here. So 2 pi x. And then we need to figure out how to express this height of the shell. That's running vertically here. So as we look at our picture, we see it would be the y value of this line minus this distance here, which is 1. So we need to take that y value, which is, in terms of x, is right here, 1/2 x plus 1. So we're going to have 1/2 x plus 1, but we don't want it all the way because it's that red line is the bottom of it, so we have this little piece of 1 in here, so we've got minus 1. And then our little thickness was dx. So again, you don't memorize a formula for how to set these up as much as you need to understand the method and then look at the picture. I said I have to find r and I have to find h from my picture. Okay, let's see what we can do then to work this. We'll take the 2 pi out in front of the integral. We're integrating from 0 to 2. And let's see right here, these ones will cancel. So I'm just going to have, we can take then the 1/2 out as well, so those will cancel. And I'm just going to have x squared dx. So we're ready to go ahead and do the integration. So I have pi and then 1/3 x cubed. We're going to evaluate that from 0 to 2. So that's going to be, putting a 2 in here, that's going to be 8/3 pi, which is also what we got when we did the washer method. And this one was actually a very easy to integrate integral, so that one might have been the way to go on that. All of these you can do them by shell or washer, but typically one is a little easier than the other.